started it, but I don't understand it that well.
No, did I start shapes and molecules with you?
No, I'm just requesting it.
No, right? So today you want me to start with that?
Yes, please.
Okay, shall we start?
Yes, please.
Now we are talking about the shapes of molecules and ions. Okay. Okay. Tell me what do you understand by the term molecule and what do you understand by the term ions?
Ions is where it has a charge, and a molecule is like the it's like a group of atoms.
Group of atoms. Okay, can you give me one example of what molecules you know?
Like water, so H2O.
Okay, so that is a molecule, right? Whole one molecule. This is a molecule. And give me one example of an ion.
A H plus ion, so a hydrogen ion.
Okay, so let's see hydrogen H plus. Okay, now what does this plus indicate?
You need to add an electron.
It needs another electron.
Yes.
It needs, that means, no. Can you please specify it me properly?
It means that the hydrogen needs to add one electron to make it.
No. Now this sign, what does it mean? This, it is ready to share one electron. Okay, it is ready to share one electron. If it is just only 1 plus, it means it is ready to share one electron. If there is any other compound, let's take an example of hydrogen itself. If I had put 2 plus, that means it is ready to share 2 electrons. If it is 3 plus, it is ready to share. Share in the sense give, okay? It is ready to give away. Plus means to give away, okay? Now if I take an example of chlorine minus. Now, plus was give away. Minus means?
To add on to it.
They are ready to accept, right? So they are ready to accept it. One negative sign means one electron. If I had to put 2 minus or 3 minus, 4 minus, these are the number of electrons they are ready to accept. Fine?
Right.
Understood why we are putting a positive and a negative sign for ions?
Because they're ready to give away an electron.
Basically to give away and to accept electrons. Now, shapes of molecules and ions, there is a known as VSEPR. Now, VSEPR stands for valence shell electron pair repulsion. Valence electron pair repulsion, VSEPR. This is a theory, and according to this theory, we are going to see the shapes of molecules, different molecules and ions. Okay?
Okay.
Now, let's take a compound, methane. Do you know what is the molecular formula of methane?
CH3.
CH3 is methane.
Oh,
CH4. This is
CH1.
methane. Okay.
Okay.
Now the central atom is carbon, right? Carbon. We have one carbon attached to 4 hydrogen, right? Now, how are
Right.
we going to put this? If I have a 4, generally for structural formula, we write it this way, right?
Right.
Okay. Now, why? Because the spreading of electron pairs is this way. That means this carbon here, it has the capacity to accept 4 new atoms. Okay, carbon has capacity to add only 4 new atoms. So here we have attached all the hydrogen atoms to all the 4 sides, right? And hydrogen, if we see, hydrogen has only one plus sign, right? That means it
Right.
share only one electron to it. That means only one atom could join it. So all the hydrogen, if you see, they have attached to only one carbon atom, right? The single carbon. Yes?
Yes.
Now, to find out what shape each and everything will give, each molecule will give, we have sets of electrons. Now, if you see hydrogen, it is bonding only with one pair of atom, right? So we'll start with that. This is for just an example purpose, okay?
Okay.
Start with first pair. Now we are starting with the first one with the 2 electron pairs. Okay, and for that we'll take an example of BeCl2. Now tell me, how many beryllium atoms do I have and how many chlorine atoms do I have?
You have 1 beryllium and 2 chlorine.
1 beryllium and 2
2 chlorine.
In that manner, which will be my center atom?
The beryllium.
Okay, beryllium will be my center atom. So can I write it this way? BeCl, BeCl. Yes, this is absolutely fine.
Yeah.
Now when I'm going to put it in a shape. Now shape, we'll do 3D molecule structures. Okay, let's see how they will be. So this is my central atom, that is beryllium, right? Okay. If that is my center atom, I have to draw 2 chlorine atoms. One here, one here. Okay, this
Okay.
shape of my molecule will look like. Now this is 2 electron pair. That means I have 2 electron, right? One example
Right.
is BeCl2. Now if you see, the electrons are spread opposite to of the opposite sides, right? This is my central atom. I have just placed them in the opposite. Now here the molecule is linear with the bond. Linear in the sense they all are found in a same single line, right?
Right.
Okay, so we'll write that molecule is linear and the degree of angle. What can you say me about the angle between these 2 electrons over here?
Would it be 180 degrees?
Very good. So this angle which they form will be 180 degree. Okay, you understood this part?
Yeah.
Okay. Second one, we'll see a third electron pair. And here we'll take an example of BF3. What is BF3?
Um, bromine and bromine trifluoride.
It is B, it is not a Br. Bromine is Br. This is boron.
Oh, boron trifluoride.
Boron trifluoride. Okay. Now, since it B will be my center atom, right? So I can write it this way. Okay. Let's put it in a 3D manner. So how it, sorry. So how this will look. Okay. So now we have formed this. I said here the molecule is linear, right? Now, what kind
Right.
of structure does it look like for you?
A triangle.
Triangle, right? With this three sides, right? So here the name we give you trigonal planar. Okay. And the bond angle, since it is three sided, what can be the angle? Linear, you told me it was 180. The possible angle which can form over here.
120 degrees.
Very good. They have 120 degrees. Okay.
Okay.
Understood this one? Can I move on to the next slide?
Okay.
Tell me if you're done, then I'll move on.
I'm done. Thank you.
The third one, right? Is the 4 electron pairs, and the example here will be what example can I give you here? Okay, let's take CH4 only, right? Methane.
Okay.
Since it has 4 electrons pair. Now draw the diagram. Now my 3D structure won't be like the one which we drew for a structural one. Okay, it will be slightly different.
Okay.
You are currently the only person in this conference.
Hello?
Hello?
Yeah, you're there, right?
Yeah, I'm here. Sorry.
Okay, fine. So this is the structure of CH4. Okay, now all the electron pairs are bonding. Therefore, the name here is tetrahedral. Okay, the shape, the name of the shape will be tetrahedral with a bond angle of 109 degree and 28 minutes. Okay, so this is the third one. Fourth one will be 5 electron pairs. Example we'll take is PF5. For 5, let's draw the structure. Okay, so this is a 5 electron pair. The name is trigonal bipyramidal.
For the 5 electron pairs,
The
what would
angle,
the angle be?
okay, they have not specified any angle over here. Okay,
Oh, okay.
because it is trigonal bipyramidal. So there is a possibility of forming a triangle and two kind of bipyramidals, right? Therefore, they have not specified a particular angle for this one. Here the name will be octahedral. Here again they have not specified any kind of angles. Okay.
Okay.
Now earlier we have seen 3 electron pairing, right? One moment, I'm just moving on to the previous slide. Okay, now when we were talking about a 3 electron pair, we had formed one kind of a structure shape which was known as a trigonal planar, right? There is one more kind of structure, we'll see that. Okay, maybe the same compound, but the structures differently posed. Here the name will be pyramidal, and the angle here will be 107. Unlike that, it was 120, right? Here it is 107. Now again, for 2-electron pair, one more possibility of a 2-electron pair. Now if you see, it is kind of bent over here, right? So they have also named as a bent shape, or sometimes as angular or dihedral, with an angle possibility of 104.5 degree. Again, for a 4-electron pair, another possibility, example of mandal. Okay, here if you see, the name over here is square planar.
I've written it down, thank you.
You're done?
Yep.
Okay, so we have seen the shapes of few molecules. Okay, whatever we have seen here is all the shapes of the molecules. You clear with it?
Yep.
Okay, now, so we have seen molecules. Now what about ions, right? We have a topic on shapes of molecules and ions. Molecules you have done, ions. Now ions also we have to treat them as the same way. Okay, what we have to do is basically we have to count up the electron pairs around the central atom. Now if I have NaCl, okay, so this is a simple atom, okay, it's okay, okay, where we have Na plus and Cl minus, right? We should always remember to put the charge whenever we are talking about ion. Okay, let's take another example. Let's take PCl3. Okay, Cl3 will be minus, P will be plus. Okay, now if this is an ion, if I had not put the charge, it will be a molecule. So if it is a molecule, how can I put PCl3 this way, right? What shape it will form? It will form a pyramidal shape. And what will be the angle when I had to draw like this? What
120.
120. Okay, so this was an angle. But whenever we're talking about an ion, it will be shaped like a pyramidal, but we cannot predict the angle because we are talking about ions, right, and not the atom. So it won't be perfectly 120 degree. You understood? So similarly we can draw the shape of an ion, but we have to put the signs.
Okay.
Right? So you understood how different shapes, different angles are formed?
Yes.
Okay. Now can I give you few molecules to solve?
Okay.
Hmm?
Yeah, that's fine.
Sorry?
Yes, I said okay.
Yeah, fine. I'll just give you the questions. Now first question is complete all bond angles. Okay, that will be SO2 some may be the repetitive of what we have done. So just have a view and try drawing them, okay?
Okay. I finished question 1.
Okay.
Shall I tell you the answers?
Yeah, this. Okay, you want me to check answers? Okay, you just tell me. Let me guess the bond angles. I'll just write it down here.
SO2 would be 180 degrees.
180 degrees. Okay.
Number 2, I found it was a trigonal bipyramidal, so that wouldn't have any angles because
5, right?
yeah.
So this is trigonal bipyramidal. Okay. I'll just write TB. Okay.
Next one is the square planar, so that's 90 degrees.
Okay, here you just have to write the bond angle. What was the bond angle here? For trigonal bipyramidal?
You didn't tell me.
Okay, fine, I got it. So it was just a trigonal bipyramidal. Okay, here it will be
90 degrees.
okay.
The next one would be 180 degrees.
90, 180.
The next one would be 90 degrees.
Here SF6.
Yes.
Okay, I have not mentioned 90 degrees anywhere. See?
Oh.
It is just
Oh.
this way. So we cannot predict whether it is a 90 degree or not.
Okay. For CH4, it's 109 degrees.
109. Okay.
NH3 would be 120 degrees.
120.
H2O would be 180.
180. Okay.
Number 9 is a trigonal bipyramid, so that doesn't have an angle.
Okay, I get it.
The next one is 109.
Okay.
I3 would be 180 degrees.
How you 180 degrees over here?
Pardon?
It's just I3, right?
The next two would be 120 degrees.
120.
The next one's 120 as well.
Okay, fine. Now here you have to just predict the shape. I mean, what shape they might be, whether they are like linear, trigonal, angular, that way.
Okay. Would the first one be linear?
Linear, okay.
Would the next one be a trigonal planar?
Yes, just trigonal planar. Okay.
The next one would be a tetrahedral.
Tetrahedral, okay.
A trigonal planar.
Okay, in this case for SO32, the shape here is always pyramidal.
Oh, okay.
Okay. Then.
Would this be linear?
Okay, because here our central angle is oxygen. Here this is angular, or we can say it is
bent.
Fine.
The next one would be trigonal bipyramidal.
last one,
and be linear.
linear. So have you understood this, how to do? Okay.
Yes.
But for all these what I have given here, you have to draw the structures, okay? For the bond
Okay.
angles, we are supposed to draw structures like this and then mention the bond angles. Fine?
Right.
Okay. I think that's molecules. Let me see if I have any question regarding that, okay? Okay, I don't think so. These are the questions which I want you to do. Okay, is there anything else you would like to ask me in this topic?
Um. If it had like an ion on, say, NH4 plus, would that change the shape?
Yeah, that will give you the shape. But only,
Would it?
see, if I'm talking about CO3 minus 2, right? It gives me a trigonal planar. What is the angle for trigonal planar?
120 degrees.
120 degree, okay? But now in this one, CO3 2 minus, okay? What is happening here is we have two electrons that are free to give away, sorry, take in, right? They are ready to take in two electrons. So here what happens is we cannot predict the angle properly. They will still be trigonal planar like this, okay? But my
Okay.
angle is not predictable in the case of ions. So these two, right? We cannot actually place the, because if you see both of them have a similar kind of a molecular formula, but the shapes, here it is a trigonal planar and here it is a pyramidal shape, right?
You are currently the only person in this conference.
So you understood here?
You were just in the middle of explaining the 2 plus charge.
Yeah, see, what I was
That
actually
does.
telling you is, where was I? Here only, right?
Yeah.
Now, both of them, they have a similar kind of structure. I mean, SO3 2 minus, CO3 2 minus. You see, both of them have, this is carbonate, this is sulfate, right? Their molecular formula is somewhat similar. Only thing is here is sulfur, here is carbon atom. But yet we have two different kind of structures formed here, a trigonal planar and a pyramidal, right? Only when they have mentioned ions, we cannot mention a proper angle to it, saying it is 120 degree. These will be less than 120. Okay, if it is less than 120, it may be 115, or it can.
You are currently the only person in this conference.
Hello. Hello. Hello.